Hello and welcome to the MassMotion version 8 tutorials. In this tutorial we will validate and debug a scene and have a look at some of the options available to us to looking within a scene in greater detail. We'll start off by looking at a very simple scene as we see before us in the main view window. This scene has some agents moving from this portal and this portal around through here to an exit portal. We also see that there's a barrier in the middle of one of our intermediate portals. To start off with, let's look at changing one of the properties of our links. If we double click on this link and we add a small distance penalty to it, which makes the agents less likely to take this route, add a 5-meter distance penalty. We can find in large scenes that these sorts of interventions are quite hard to keep track of. In order to understand exactly where we've made these sorts of interventions, we can select our entire scene and we can audit the scene to see what's going on. If we audit by object, we see that one of our links shows up, and we see that this particular link has a unique distance cost with a custom value of 5, as we said. So this enables us to audit the scene and look at any properties that are non-standard. There are other ways that we could look at what's going on within our scene. Another way is the find tool. We can look at any particular piece of geometry within the scene and we can find it to see in which different collections or which different groups of things this object is being used by. So if we select this floor and we say find in any, this will see if this shows up in any actions or in any filters or any specific groups. We click this and we see that this is in a pre-existing collection called the exit area. This can be used on portals, floors, links, and any other piece of geometry. Let's start by running our scene, and then we can have a look at investigating how the agents move in a bit more detail. To start off with, we will validate the model. Under the Simulation and Analysis tab, we see we have the Validate button. There are several different types of validation. There is validating objects and settings, which will look at every piece of geometry and any of the settings such as runtime, duration, working folder, things like that. And then we can also look at the network, which looks at whether separate movements that have been assigned by any portals or journey events or anything like that will actually be valid. Let's quickly validate the objects and settings. And we see that we have one error in our issue log. This says that there is one of our links which has not been constructed correctly. If we click on this link and we can then zoom to it in our view, we see that the ball line is not connected to the floor. This is shown up in grey, so it's as simple as we can move this and make sure that it is now green on both sides, so it's valid. Now we can get out of this, and if we validate our objects and settings, we'll see that everything was successfully validated and no issues were found. We can now run our simulation and take a look at the different types of ways in which we can produce a MassMotion dataset. There are several different types of runs we can do. The standard run and the default for all of the MassMotion simulations that will be run is the standard console. This gives us a certain amount of detail, and we will go through this shortly. There are also two other types. There is the debug viewer, which we will have a look at in detail, and also a multi-run mode, which allows us to run multiple instances of the same standard console run. This is potentially useful when we have models that have a high random series of events, such as differing headways or random headways for train events or things along those lines. Let's start off with a standard console run, and we'll just overwrite the one that we previously have created. If we run this, we see that our agents are created quite quickly. It will give us a breakdown of minute by minute agent population and how long each one of those single minutes took. We can see that the overall duration of the model was 15 minutes, and that took us 2 seconds to run. We can also see that we created 511 agents in this model, 6 of which remain in the scene. We can take a look at this population in a bit more detail afterwards. If we close this console run, we see that we now have a result set and we see people moving through the scene. If we need a little bit more information in terms of how these agents are moving through the space, we can try a different type of simulation. Changing our standard console run to a debug viewer, we get more options in terms of how we can interrogate the scene. One thing that we're able to do is the ability to pause the simulation halfway through or a certain point through the scene. Let's go and we will set it for 30 seconds into the scene. This is potentially useful for areas of the model where you know there are issues in terms of agent movements, or if you have previous errors and you want to be sure what's going on. So we'll set our breakpoint for 30 seconds and we will start our debug run. We see from the debug run that we get a slightly more involved set of viewing options than our console run. For starters, we have the 3D view. We also have a list of every object in the scene. We have our standard console here, and we also have an issue log at the moment, which is thankfully empty. We can also see that we've paused automatically at 30 seconds due to the breakpoint that we've set up. Within the debug mode, there are several different ways that we can look at the scene. One key component of this is the inspector window, which is off by default. We can find it by hitting the I button here. What this will give us is an extra tab that allows us a great deal of information about any object within the scene. For instance, if we click on a floor, we can see not only the name of the floor and the type of geometry that it is, but also things like its physical dimension, if it has any limits on flow rates or anything like that for a link. It will also give us information about the amount of people who've ever been on that floor, how fast they've been moving, and things like that. This is potentially very useful when we're looking at complex scenes with lots of linked geometry or different types of escalators and so forth. We can also take a look at the agents themselves. Looking at our single agent that we have in the scene, at the moment we see that we can determine what they're currently aiming towards. We can see their current floor that they're on, and we can also see their waypoints, so where they have come from. We also see their instantaneous level of service. If we play the simulation and get a few more agents, we can also see a few more things. If we click on an agent, there are more options available to us. If we go to the display menu by right-clicking on an agent, we can also display what is called their neighborhood forces. What this does is this makes visible that the fact that every frame we have, the agents are aware of other agents around them, and this will change frame by frame and be dynamically updated. This will govern things like if agents move due to congestion and choose different routes if others are too busy. If we remove this, we can also have a look at an agent's route costing. What this does is this gives us a very simple list of why agents are choosing the routes that they're choosing. For instance, this agent has 3 options. He has moving through this link, through the closer link, and back to his portal. We see that he's not really allowed back to his portal because that doesn't get him any closer to his goal. We also see that there's a breakdown in terms of the total cost of an agent. This includes the distance, the queue cost, an opposing flow cost for cross-flow and moving into large crowds, and also a vertical circulation cost. This is then blended together in MassMotion to develop a total cost, and we see that the agents will choose the green, more favourable option. There are other things that we can do in the debug mode, such as looking at an obstacle map for a floor. What this does is shows the areas in which an object or an agent cannot move. We see here that despite the fact that we have some interesting 3D geometry, we see that only the area around the base of the structure is off limits to agents. So agents will move around these red zones and move through the rest of the obstacle map. This is potentially useful for large 3D spaces where you can potentially run the risk of having columns impacting on floors above or floors below. Obstacle maps allow us to investigate our floors and see what's going on with our scene. So if If we hide this, we can unpause and finish the rest of the scene. It's worth noting that, especially with the 3D viewer on, that the debug mode is significantly slower than the console mode. The console mode is set up to efficiently run simulations as quickly as possible, whereas the debug mode enables several other parameters that we can access. As a result, the debug mode is used for investigating scenes in great detail, especially if we have agent errors. It is not really recommended for regular use cases because it does take significantly longer. Now we will let this finish, and then what we will see is we will be able to look at some other ways in which we can interrogate these agents even after we've completed a simulation run. So if we close this, we see we have our simulation run back in the regular scene window. There are several things that we can do here, such as looking at the end state of agents. For this, we're going to use an agent filter. Under the Simulation and Analysis tab, we can create an agent filter. This allows us to create a subset of agents within our scene. This is potentially useful, especially in the case of complex models where we have potentially agents removed with errors and we want to find out why, or large numbers of people stuck within the simulation at the end of the runtime and we want to find out exactly what their journey is. If we take a look at the agent filter, we see that there are numerous things we can do. What we're interested in is the end state of the agents. So if we scroll down to end state, we find that we have three options: in simulation, exited with success, and exited with error. For now, we will select in simulation. What we will now do is we will take a look at our simulation run, and we will enable an agent filter to make sure that we will color all of our agents that are part of our filter, which we will select here. We will now show that moving forward we see all of our regular agents in orange, and we see any who fail to complete the scene will show up in green, and predictably they show up at the end of the simulation. This is potentially really useful for looking at large scenes where you have multiple populations moving through multiple different areas of the space, and also as an error checking mechanism. We can also investigate each agent on an individual basis. If we select one of our agents, right-click and move down to the Observe button, we find the Observe window gives us similar functionality to the Debug window. This will tell us what created the agent in terms of a journey, if it was a timetable or a circulate event or any other type of demand event. It will tell us what time they began in the simulation and what time they ended. It will also give us the instantaneous level of service over time, and also show the full route that they've taken. This can be highlighted to show the entire route of which they've moved through. This will also give us the tokens and actions that the agent uses or is given at any point throughout the simulation. For more information on the analysis side of things, including more on agent filters, please consult the analysis tutorial. Thank you.